In this and the next few videos, we're going to investigate the area of autoimmunity. Some relevant readings are chapters 14 and 18 in Cellular and Molecular Immunology and Janeway's Immunobiology, chapter 15. We'll start off by considering the teleology of the immune system, what it's really there for, the categories of immune dysfunction, and when we consider that, I'm going to use the word misorder, and I'd like to avoid the term disorder, because disorder suggests that the immune system has somehow become chaotic and has no principles ordering its behavior whatsoever, which I think is misleading. In fact, what I'm hoping to convey is that it's likely that the immune system is following ordered principles, but those lead to the emergence of inflammation that causes symptoms of disease. We'll then consider mechanisms of autoimmunity, some genetics behind it, and then look at a couple examples. There have been a number of theories of how and why the immune system does what it does. In the early 1950s and 60s, the dominant theory was that the immune system responded to non-self, and it made a fundamental distinction between things that were self and things that were non-self. Later, that was modified a little to include microbes and non-microbes, but this theory was largely championed by Charlie Janeway and has been around for decades. A more recent theory that arose in the 1990s and early 2000s was the danger hypothesis, and that was really enunciated by Polly Matzinger, who argued that really the immune system is there to defend us against danger. Either way, it's reasonable to say that defense against infections, especially microbial infections with viruses and bacteria, have been the main evolutionary driving force for the development of the immune system. And de facto, the immune system, I think, is a network that analyzes matter in the body. And in that sense, it functions in a way parallel to the nervous system, which is a complex network of equal, if not greater magnitude for dealing with energy, such as light, heat, sound, pressure, and vibration. Both of these systems are there to help the host survive. This figure, taken from a paper written by Polly Matzinger, really displays in a kind of Venn diagram manner the distinctions among the different organizing theories of immunity. The SNS, or self-non-self theory, postulates that antigens come in two big categories. A is self in pink, and B, and all of the subcategories, are non-self in light green. To that theory's mind, there would be an immune response to everything in B, which includes things in D, E, and F, but there would be no response to the things here, A and C. The infectious non-self theory is a little more constrained and argues that there are some non-self materials that the immune system would not respond to, and so it responds only to these infectious PAMP-armed substances, like microbes and some parasites. So that would include those microbes that are dangerous in E, and those microbes or infections that are non-dangerous in F. Lastly, the danger hypothesis suggests that there is a finer distinction where what really the immune system is interested in is what is dangerous. And that not only includes a number of infectious and non-infectious non-self materials, but also some dangerous self materials. And certainly an example of that would be malignancy, where a cancer cell, even arguably, if it's become infected by a virus that has integrated some of its DNA into the host genome, is still largely self. And the infection, or just a mutation in general, has driven the normal body cell to become cancerous, and that represents a danger to the host, and the immune system would appropriately attack that material. So thinking in terms of the source of materials that the immune system analyzes and the status of those materials, we can divide the universe of antigens into four components. There are those that are external to the body and dangerous, like microbes. There are those that are external to the body but safe, either beneficial or neutral. There are those that are part of the body itself. They are internal antigens, but they've become dangerous, say by mutation. And there are those that are internal to the body but are safe, and represent no threat. And this is an indication of what occurs when the immune system accidentally does what it ought not to do, so to speak. Meaning, an external dangerous substance should be attacked, but failure to do so generates immunodeficiency, with recurrent infections as a hallmark. In the sense, the opposite is true when the immune system responds inappropriately to an external but safe material, and that, in the large sense, is hypersensitivity reactions, a subclass of which are allergic reactions. Lastly, and the focus of these videos will be, what if the immune system encounters internal safe materials? It ought to leave those alone, but if it attacks them, that's the pathway to generating autoimmunity.